How do we study a volcano whose eruptions humans have never recorded? I'm Geoff. I'm a PhD student at University of Auckland. I'm originally from the United States. I'm studying volcanic hazards at Mount Taranaki, which is a stratovolcano on the North Island of New Zealand. Stratovolcanoes grow in cycles. So a volcano like Taranaki erupts for a while and then it stops and then it erupts again. And during those periods, it's erupting sometimes very loudly, very violently, and sometimes very quietly. So that's how a volcano erupts in time, but a volcano also erupts differently in space. So the volcano doesn't grow evenly on all sides. It erupts in one direction for some time and then in another direction, and then maybe returns to that first sector that it was erupting in for a new eruptive cycle. So we're using a bunch of different methods to look at the ages and the emplacement temperatures and the conditions at which the deposits from the volcano were deposited, including paleomagnetism, sedimentology, geochemistry, radiocarbon dating, and field geology. We collect our samples from a number of different locations on and around the volcano, and one of the places that we go is up to the summit of the volcano to take samples, in which case we have to carry a number of things up to the top, including a chainsaw converted into a drill and a lot of water to put through the drill. Once we're at the summit, we collect a number of cores that we orient, and then we can take them down to the paleomagnetism lab in Wellington and the geochemistry lab in Auckland in order to collect our data. In the labs, we use a number of different pieces of equipment to analyze the samples, including magnetometers to look at the magnetic material within the rocks, and X-ray fluorescence detectors to look at the geochemical composition of the rocks. And what these can tell us are the age of the rocks as well as the conditions under which they were emplaced. There are no written records of any of the eruptions that took place at Mount Taranaki, which means that the deposits we study and the lava flows we sample are our only means of recreating the record of eruptions at this volcano. The reason we care about where a volcano is erupting is because it lets us prepare better for a volcanic hazard. So right now, when we look at the hazard map of Taranaki, we prepare equally in every single direction at a certain distance. But if we can get a better idea of where the hazards are focused at any given time, then we can prepare much more effectively for those hazards.